All right, in this video, we are going to conduct a chi-squared test of independence, and we're going to use the Numworks calculator. It's going to do most of our work for us. Now, we are going to use the procedure that we framed out in a previous video on how, it's basically 6 steps on how to do a chi-square test of independence. It's not going to eliminate the steps, and it's not going to eliminate the procedure. All it's going to do is it's going to allow us to not have to do a lot of calculations on our, by hand or something like that. Now, we're already doing step 4, where we identify the critical value of the chi-square test statistic. We were already doing that in Numworks. If you recall, we would go to distributions, then we would select the chi-square distribution, we would enter the degrees of freedom, then hit next. Then we would switch to a right tail, and then we would enter our alpha in the far right box where we would see the p-values, and then the chi-square, the critical chi-square value, would be in the middle box. But we can also use the Numworks calculator to identify the expected values matrix, or the expected values contingency table. We can get the chi-square statistic, which is awesome because that's really challenging to add up, especially if there are a lot of cells. And then we can also get the p-value in Numworks. And the way we do that is we go to, we select the app in Numworks called Inference. And once we get in there, there are 2 choices. We choose tests. Under tests, one of the choices is chi-square. And then once you go into chi-square, there's 2 choices. One of them is homogeneity / independence. That's one we're going to pick. And then once you get in there, you'll see that you can enter values for an observed matrix or an observed contingency table. And so right after you do that, you enter all of the values from the observed values table, and then right under that, you would then enter the alpha for the test. And then once you've done all that, clicking on next will then show you the expected values table, and then clicking on next after that will show you the chi-square test statistic and the p-value. It'll actually already also give you the degrees of freedom, but by this point we already needed the degrees of freedom to get our critical value for the chi-square, okay? So you can see that we can get everything that we need for our test statistic pretty much from the Numworks calculator. So what we're going to do right now is we're going to do an example. All right, suppose a sample of adults were asked if they are under 45 or 45 and older. And also they were asked if they mainly, this should be a they, if they mainly get their news from television or online or from some social media platform. Then it says conduct a chi-square test of independence at the alpha equals 0.01 level to see if age group, which is over 45 or under 45, 2 categories, is related to news source, which is 3 categories, TV, online, and social media. And here is our observed matrix, and here is our expected values matrix. Now, of course, the first step is going to be to identify the null and alternative hypotheses. So H sub O is going to be that the 2 variables are independent. So the 2 variables are independent of each other. Okay. And now we'll move on to the alternative hypothesis, which is that the 2 variables are not independent of each other. So are not independent. You can also see I did in a previous example where we said the alternative hypothesis is that the 2 variables are not, or are related. Not independent means the same thing as they are related, okay? All right, so if I stated our null and alternative hypotheses, now let's identify our alpha. It's right here. So alpha is 0.01, and so we'll say reject H sub O if our p-value is less than 0.01. And then we also need our degrees of freedom. And so remember, degrees of freedom is equal to the number of rows minus 1. So 2 rows minus 1, that's 1, times the number of columns. 3 minus 1, that's 2. So 3 minus 1 is 2. So 2 times 2 minus 1 is 1. 2 times 1, so degrees of freedom are 2. Okay? All right, now let's move on to step 3, which is filling out the expected values matrix, which we're going to do from Numworks. You may say, well, hey, where are the total columns? Where are your sum columns? We don't need them when we use the Numworks calculator. Okay, so all we're going to do is we're going to enter these 6 numbers into Numworks, and it's going to give us these 6 numbers. So let's switch over to the Numworks calculator. And we're going to go down to inference. That's what we said. We're going to go to inference, hit OK. We're going to go to tests, OK. And then we're going to go down to chi-squared, OK. And we don't want goodness of fit. We want homogeneity and independence. Hit OK. And look, here's where we can enter in our observed matrix. And so we're going to do 25 and then 25. So in this first column, we're going to do 25, then arrow down to 25. Now I'm going to go up and over. Now the next column is going to be 11 and 53. So 11 down and 53. Okay, good. Up and then over. And then 16 and 56. 16 and 56. And we're done. We've got all 6 of our numbers put in. And so now we're going to arrow down to the significance level, which we're going to change to 0.01. And then we're going to go down. Now we're going to hit next. And it's going to give us, here it is. Here's our expected values table, okay? Now, I want you to notice that it's actually giving them to us in 2 decimals. That can be a problem sometimes. It could be that you may have to, if you need more than 2 decimal places on your expected values, let's say for a homework assignment or something like that, you might actually have to calculate that one by hand on your own, or use a different software. Okay, so we're going to do 13.98 here. So 13.98 here. Then here we're going to put 35. Is that a 35? No, 3602. All right, so 3602. Then we're going to get 1789. 17.89. And then here is going to be, looks like 46. Yep, 4611. So 46.11. And then here's 20.13. 20.13. And then here is 51.87. 51.87. Isn't that great? Numworks did the whole thing for us, okay? Now we're going to move on to step 4, which is the critical value for the chi-square. All right, so for the critical value for the chi-square, we're going to go back to the Numworks calculator. Only now we're going to go over to distributions. We're going to hit OK. We're going to go down to chi-square, hit OK. It says degrees of freedom. We already know that. It's 2. Execute, and then next, okay? And now we got to change it to the right side shading, which is down here at the bottom. And then over here, our alpha was 0.01. Is that correct? Alpha point, yep, 0.01. And we're going to hit execute. So our critical value is 9.21034. 9.21034. 9.21034. And so we're going to say reject H sub O if the actual chi-square test statistic is greater than 9.21034. Okay? All right, now we're moving on to step 5, where we have to calculate the chi-square test statistic, but we're not going to calculate the chi-square test statistic. We're going to go to Numworks, but we have to exit here, and we have to go back into inference. Now, it should have saved our space. Let's see. It sure did. Look, here we are. We're back to the chi-squared. We're back to the expected values table. And now we're going to go down here to next. We see that the chi-square test statistic is 16.92337. That was really easy. 16.92337. Now if we go back, we have step 6. Here's our p-value. Oh, it's got this weird 2.114 thing, e to the 4. Do you remember what we have to do here? We have to move this decimal point. This e negative 4 means move the decimal point over 4 places. 1, and then 2, 3, 4. When we move it, the 2, 3, 4, we're going to put 3 zeros in. Okay, so let me show you here. P equals, we're going to have 1, 2, 3 zeros, and then 2, 1, 1, 4. 2, 1, 1, 4. Now it had the decimal point here, and then we have to move it 1, 2, 3, 4, so it'll end up right here. Okay, so let's go ahead and do this, and here it is. So here's the p-value, 0.002114. And now we can see very clearly that the chi-square test statistic is greater than 9.2134, and we can see that the p-value is clearly less than 0.01 because it's 0.0002114. Okay, and so we can reject H sub O. Okay, and that is one example of how we can just use Numworks to get all of our stuff for doing a chi-square test of independence. Let's do one more example. All right, suppose there's a gym and they survey some of their members and they ask them, do you work out for cardio? Do you work out for strength? Or do you train for a sport mainly? And also, what time of day do you typically work out? Do you work out in the morning, in the afternoon, in the evening, or late? That's 4 categories. So we're going to conduct a chi-square test to see if these two variables are related. All right, so here's our step 1. State the null and alternative hypotheses. Null hypothesis, the two variables are independent, not related to each other. Alternative hypothesis, the two variables are related to each other. Okay. Then step 2, we're going to identify the alpha, which is 0.05, and that means that we're going to reject H sub O if our p-value winds up being less than 0.05. We also need our degrees of freedom. And our degrees of freedom, well, look, we have 4 rows, minus 1 is 3. So that's going to be 3 times, and then we have 3 rows, minus 1 is 2. So 3 times 2. So our degrees of freedom are going to be 6. Okay, all right, well, that's good to know. Step 3 now is going to be to create the expected values matrix, which we are going to do in Numworks. So let's go to the Numworks calculator. We'll go down to inference over here. Okay, we're going to select tests. Then we're going to go down to chi-square. Okay, we're going to select homogeneity, independence. Okay, and we're going to enter our matrix here. We have 48 here, so we'll put 48, arrow down. Okay, then we have 18, 36, 10. 18, 36, then 10. Now we're going to go to the next column. All right, then we have 33 and 9. 33 and 9. And then we have 21 and 8. Then move down. 21, and then move down, and 8. Now we're going to go to the last column here, and we're going to have 6 and then 10. So 6, then move down, and then 10, then move down, and we have then 15 and 3. So 15, move down, and then 3. And we said that our significance level is 0.05, which is good. It's already 0.05, so we don't have to change that. And then we'll go to next. Okay, we hit next. Here is our expected values table. Let's move over a little bit. There we go. Now we can see the whole thing. We'll start with 44.9 and 19.1. So 44.9, 19.1, Then we've got 37.16, 37.16, then 10.84, 10.84. Now let's go to this column. We got 28.47, 28.47, and then 12.11, 12.11, then 23.56, 23.56, then 6.8. So this one gave us 3. Oh, because it's only one number. 6.871, 6.871. And now over in the third column, we have 13.63, 13.63, and then 5.797, 5.797, and then 11.28, 11.28, and in the bottom we have 3.29, 3.29. All right, and step 3. Step 4, we're going to identify the chi-squared critical value. And remember, to get the chi-squared critical value, we're going to go into the Numworks calculator. We're going to switch over to distributions, hit OK, go down to chi-squared, OK. Degrees of freedom this time is 6. So we're going to put in 6, then next. We're going to switch over to the right side shaded here, move down there, OK. Now we're going to go over to the p-value, and we're going to put in 0.05 because that's our alpha. Hit execute, and our chi-squared test, the critical value test statistic, or excuse me, the chi-squared critical value is 12.59159. So 12.59159, and so we're going to say reject H sub O, hang on, that's pretty ugly. Reject H sub O if the chi-squared test statistic is greater than 12.59159. That was step 4. Now let's move on to step 5, where we actually identify the chi-squared test statistic, which is really easy, because we're now going to go back to inference, okay? And they saved our spot. Look, we're in the expected values matrix. Go down to next, hit OK, and look, there's our chi-squared, 10.93092. 10.93092. And we can also get our p-value, and our p-value is 0.090535. 0.090535. Okay, and look what we have here. Okay, our chi-squared is 10.93092. That is not larger than 12.59159. So we're gonna do not reject. It didn't make it. Also, our p-value is 0.09. That's not smaller than 0.05, it's larger than. So we are going to do not reject H sub O. And so we do this test, this sample does not support the alternative hypothesis that that the kind of exercise that people do at the gym is somehow related to what time of day. That hypothesis is not supported, okay? And so we've done 2 examples here, and I showed you how to do a chi-squared test of independence using the Numworks calculator. Hopefully that helps you out a lot, and hopefully you can get your work done more accurately, possibly, and maybe even faster.